In this section, we're going to have a look at the three main index laws. Now you'll notice in the first sentence it says, when multiplying numbers with the same base, we add the indices. And what we need to do here is just to make sure we're clear on the meaning of these words. And there's one other word down here that we need to look at, and that is the word power. So what do these words mean? In this number here, you'll see there's a 3 and a 10. Now all of these words are wrapped up in this shape here, this shape of numbers if you like. It's a symbol. And what we've got right there is the base. And up here we have the index. So when we're talking about bases and index, that's what we're referring to. Also down here the word power, this is exactly the same thing as the index number. The power and the index number are the same. So let's go through now and have a look at these three laws. First one is, it says when multiplying numbers with the same base. Now that's a very important point. The bases have to be the same. We add the indices. So here we have an example, a base of 3, another base, so they're the same. Add the indices and we get 3 to the power of 10. That's rule 1. Law number 2 says when we're dividing numbers with the same base, we subtract the indices. So there's the base, there are the indices, we subtract them to get our final answer. And the third law that we look at talks about having a power of a number raised to a higher power. So what we mean by this is there's the base, there's a power, 3 to the 6. We raise it to a higher power. When we do this, we multiply the indices together to get the final answer. Now down here, we've got the laws summarized in what we call a generalized way. What we mean by this is that we've got letters to represent numbers. Up here we've just got the bases of 3. Here the base could be any number and the power and indices could be any particular number. So it simply says as long as the bases are the same, when we multiply, we add the indices. Here the bases are the same, we're dividing, we subtract the indices. And here whatever the base is, there's a power, it's raised to a higher power, we multiply the indices together. The mn together means m times n. Now we're going to apply the laws. So it says here, show by writing in expanded form that these laws actually work. Now this takes a little while, but it's a very important thing to see. So if I take m4 and multiply it out in expanded form, and then I multiply by m3 also expanded, when I put these to a power, we've got 1, 2, 3, 4, 5, 6, 7. So our base m is to the power of 7, and that's why this one works. Let's have a look at B. This time we'll write the m expanded at the top. So there's our 5. 1, 2, 3, 4, one more. We need to have a division, so we'll put a line underneath here and we'll put our m squared underneath. Now we can cancel. So what we have is m, our base, to the power of 3. So that's how we show that m5 divided by m2 equals m3. And finally C. Now C is definitely a longer idea. This is why index form notation is so good. So m to the 4, I'll just write the question down here, m to the 4 raised to the higher power of 3. That means that we've got 3 lots of this. So first of all I could write this out. So that's 3 lots of m to the 4, that's what this means. Then writing it out in expanded form, you can see will take a moment, but I'd like you to do that. So we need to do this a couple of times more. So that's 2 lots, and then our third lot. So if we count all these, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, which is what we expect, m to the 12, and that's why the law works. 4 and 3, 3 lots of 4 is 12. So you can see that by doing the index laws, or by putting these into practice, we can actually save quite a lot of time. Your calculator can help you to see how these things work as well. So it says here, use a calculator to evaluate the following expressions when a is equal to 3. Evaluate means simply to work them out, to get an answer. And here we've got a, we're going to substitute it in and work it out with our calculator. So you get your calculators out and try these things out. So we've got a to the 4 times a to the 3. That means that we've got a, remember, is a 3, so we've got 3 to the 4 times 3 to the 3. Now if you use your calculators, you'll get the following answers. 81 for 3 to the 4 times 27, which is 3 to the 3. Now the key that I used on my calculator, I have a key, there's an X value and there's a little square like this to indicate that we're going to put the indexes or the powers in. So you need to find your calculator key as well. Let's just finish this one off here. 81 times 27 with our calculator, you'll find this is 2,187. All right, let's have a look at number 2. This way we're going to do our shortcut. We've obviously seen here the index law is 4 plus 3 is 7. So if I put in 3 to the power of 7 straight away, using my key, 3 to the power of 7 comes out to be 2,187. So that's another way of showing that the index laws work. Let's look at B now. It says, does the value of A4 times A3 equal the value of A7? Very simple answer. 2187, 2187. So the answer is yes. Let's take a few examples and use our laws to actually simplify these problems. So in this case, we say use the index laws to simplify. So our index laws say, well, they're the same bases, so we add our powers or indexes, 7 plus 3. So our answer here is y to the 10. Let's have a look at an example where there's a division. We know our law says that we've got to subtract our indices. So we would say y to the 18 divided by y to the 17 means subtract. So let's do that. 18 take away 17, which gives us y to the power of 1, which is the correct answer. But normally when we've got a power of 1, we just write it down as 1 and we assume that there's a 1 there. That's a good thing to remember, that if you've got a letter with no visible power, it's going to be a 1. Our final example on this section is an index that's raised to a higher power. So our law says take the power inside and multiply it by the higher power. So our answer there is b to the 5 times 3, which is b to the 15. In this last example, we're going to have a look at why the index laws can't be used in these particular cases. Now you'll notice that we've got a p to the power of 3 times q to the 4. The best way to see why this doesn't work is to multiply them out in expanded form. So there's p times p times p, and here's q times q times q, and there's another one, q to the 4. Now I think you can see quite clearly that you can't group these together. So in this particular case, you can't match them up with these, so that just simply stays as p to the 3, and this one over here is q to the 4. So there's no ways at all you can add the powers here because the bases are not the same. And likewise, if I take this one here and write it out, so we need 6 of them up here, 1, 2, 3, 4, 5, and 6. All right, and we're going to do a division, and we're going to have 4 n's, 1, 2, 3, 4. Now if we try to cancel these out, you'll notice that we can't because there are no m's in the denominator and no n's in the numerator. They just can't cancel out. So in fact, the answer just stays like that, and I guess we could write it out as m to the 6 divided by n to the 4, but we can't do any more with that. In other words, we can't use the index laws at all.